Welcome to another exercise in the workbook Statistics. This time I'm going to focus on an exercise on the normal distribution. So let's have a look at our exercise. The average banana produced in Costa Rica weighs 130 grams, with a standard deviation of 11 grams, and the weight of bananas can be considered as normally distributed. That's a valuable information because this tells us we're going to work with the normal distribution. Then we have as a first task, all bananas weighing less than 110 grams are winnowed. What is the probability that a random banana is winnowed? Second, bananas of class A weigh between 125 grams and 145 grams. Assuming that the daily output is 118,000 bananas, how many of those qualify for being rated as class A? Finally, the third and last of our partial questions. What is the probability that a banana weighs exactly 130 grams? Well, we know it's about normal distribution, so let's start with part A. Part A, what we're looking for is that the banana should weigh less than 110 grams. We also know from the exercise that we have a mean of 130 and we have a standard deviation of 11. That's actually everything we need, because then we can start first off with standardizing the 110. Standardization means we're going to subtract the mean and we're going to divide by the standard deviation. If we do this, this yields us a value of minus 1.82. Since this is in this big phi means we have to look this value up in the table for the standard normal distribution. Well, the tables usually start at 0 and then only report positive values. So we cannot look up this value. But we can make this positive by simply more or less drawing the minus in front, meaning replacing this with 1 minus phi of the positive value. So instead of looking for the minus value, we're going to switch this around and look for the other side of the distribution. Well, that's a neat factor. We can look up the 1.82 in the table and we find there a value of 0.9656. We're going to subtract this from the 1 and we get as a final result 3.44. So the chance that a banana will actually weigh less than those 110 grams is just 3.44%. A little bit less than 3.5%. Well, that was already the first part. So let's directly continue with the second one. In the second one, what we're looking for is first off the probability that a banana will be of class A, meaning that the banana weighs something between 125 and 145 grams. Once we have this probability, we just have to multiply this with the overall output of bananas, which was the 118,000. Well, how do we get about this one? Whenever we have an interval like this from a lower to an upper bound, we're first going to calculate the probability that x is smaller or equal to the upper bound minus probability that x is smaller or equal to the lower bound. So it's first this one, the upper bound, then the lower bound. We're going to use the same average, we're going to use the same standard deviation here. So we're going to standardize the 145 and the 125. Both cases subtract the mean, divide by the standard deviation. If we do this, we get first off a 1.36 and second a minus 0.45. Well, we already know from the exercise on the last slide on part A how to carry on if we have a negative value here. So we're going to replace this with 1 minus phi of 0.45. Due to the minus in front of it, we will get minus 1 and minus a minus give plus. So we have to look up the value 1.36 and the value 0.45 in our table, giving us these two results. And if we calculate the whole expression, we get as a final result 58.67%. So the chance that a banana is of class A is, well, 58.67%. However, in this exercise, we are not asking about the probability. We are asking about the amount of bananas, so we have to multiply this with the 118,000 bananas. If we do this, we get as a result 69,230.6. So roughly like this, roughly these many bananas will be of class A. Well, that was then already the second part, leaving us only with one final part. And the final part, the exercise part C, is actually pretty easy and pretty straightforward. Here we're looking for the probability that a banana weighs exactly 130 grams. So it's x being equal to 130. Here we can recall that the normal distribution is a continuous distribution. So the probability of getting one particular result, one exact result, will always be 0. We can explain this with multiple factors, but whenever we have something where it says should be exactly like this, the result will always be 0%. Well, that's then already everything there is to this whole exercise. I hope you enjoyed it. I say goodbye and see you next time.